All right, so here is an HVDCDC converter, and it's been modified. It's not connected to power right now. You basically take the cover off like I just did, and you change these two resistor values. I currently have them set to 9.1 and 11K. The default value is 10K on both of them. And doing that allows us to operate, it looks like, up to about 245 volts or thereabouts. Let's go back on. Okay. So we've just got that sitting in place, good enough, in case it explodes or something. This is our input power source. It is a 300 volt, 11 plus amp device, so it can certainly source the 1000 watts max that we could pull here. And then on the output side, I have just a standard what's up meter here to tell us how much current, how much power we're pulling. This is all 4-wire sensed by this device here, and we are providing our aux power from this supply up here. This is just a Kickstarter, like a bootstrap, because the DC-DC will not turn on unless 12 volts is present, both here and on the signal logic, which I have hooked up here. And so that's just a booster. We just have it at 10 volts. So as soon as the HVDC turns on, this is just going to get overridden. Because it's a single quadrant supply, it'll just do nothing. And over here we have our programmable load, and we have an aux unit on it here, which is being cooled by a fan here. There's also a fan blowing it from the bottom because we can push a lot of current through this, as you will see. So what I'm going to do is I'm going to turn our power supply on to 240 volts. Again, this is a hacked value here because out of the box it'll only do about 220 volts, 218 volts or whatever. So we're going to pop this on. As soon as we do that, you can see that the voltage up top here is no longer 10 volts or whatever, it's now 14. That's the output voltage of the DC-DC. And we don't have a load yet, so you can see that our load current is 0 right here. And so we can basically turn our programmable load on, and that's doing 21 amps at 240 volts. And we can also come in and plug our little aux unit on, and now we're doing 51 amps or thereabouts. And I've got this little thermal imager just so we can see stuff getting hot. You can see that, sure enough, if you convert joules into heat, they get hot. So physics are happy. But yeah, so now we can basically increase the voltage here, and eventually it will turn off. So I'm going to go to preview mode here, and at 50 amps, I think it's about 244 volts that so the supply did just turn off there. The recovery, I can actually smell the heat coming out of that. I mean, we're pushing 800 watts into heat there. So if we come back down now, find our recovery voltage, which might never happen because of the way this test is set up. I don't think my bootstrap can pick up. I need to actually unplug this. So let's see, we'll unplug that. Yep. And so we still haven't recovered yet. So at this point, we can actually figure out the kick on voltage. Which still hasn't happened. There it goes. So it's about 232 volts in this configuration at no load. So if you go above that 244 volts, then you have to drop back down to 232. So for that case, we probably need to go to a higher offset voltage. So that resistance pair needs to be lowered from like the 9.1K and 11K to maybe like 8K and 12K. But you know, regardless, it definitely is working at a higher voltage. At this voltage, it could very easily be used with a 60S lithium solution, which is awesome. So thank you to EEPROM for figuring this actually quite simple hack out. You know, once you've reverse engineered the whole thing, it's surprisingly easy when you know how the circuit works to change it. And that should be pretty obvious, I guess. So anyway, that is pretty awesome. We now have a HVDCDC that can crank out the power. And what I'm going to do is I'm going to leave this running for a little while. I need to get a little bit better of a fan setup here to do a little more forced air cooling. I might just throw this in like vegetable oil, because then it will be cooling into the oil. So anywho, yeah, I want to leave it running for a few hours at a higher voltage. Probably not going to test that right now. This is just a fun little does it work, and yes it does. So now I'm going to get back to LIBCM. As always, thanks for watching.